Okay, without looking at the solution, I've got vector A, it's 5, 7. What does this 5, 7 mean to you? What does the 5, 7 mean to you? 5 what?
5 steps to the right.
Okay, 5 units to the right and
Then 7 to the upwards.
7 units upwards. Okay, so can visualize? 5 and 7. Okay, so that is vector A diagonally, right? What is the magnitude of vector A?
5 square plus 7 square.
Square root 5 square plus 7 square. Okay, very good. So you get 8.6 units. What about B? What does this vector look like? Negative 4, 3.
Negative 4. Negative 4.
Okay, so left side, how many units? 4 units, and then 3 upwards. So can visualize it? Okay, join the starting and the ending. Find the magnitude. What is the magnitude?
Negative 4 square plus 3 square.
Okay, the negative 4 must have a
Bracket.
bracket. Yes, very good. So we have 5 units. Now, I want you to think about the magnitude of A plus B, given these answers. Okay? What is the magnitude of A plus B? 13.6? 13.6? So you are saying that magnitude of A plus magnitude of B equals to magnitude A plus B. Is it?
Actually,
No? Change your mind now? Can you give me one very simple reason,
you plus the
one very simple example why it is false? Huh? If I try to draw, okay, I give you an example first. Let's say I've got vector x and vector negative x. What is the magnitude of vector x? The magnitude of vector x is the same as magnitude of negative x, right? The same, right? So when I take magnitude of x plus magnitude of negative x, I am supposed to get 2 times the magnitude of x, correct? Correct? Right, they are the same thing, ma? Okay, what about magnitude of x minus x? 0. So, are they the same? No. What is our conclusion? Our conclusion is that magnitude of A plus magnitude of B is not always equals to magnitude of A plus B. Why not? Is your question why sometimes can? Okay, very good. What if my A looks like this and then B looks like this? You get it? In the same direction. Then let's say the magnitude of A equals to 1, then the magnitude of B equals to 2, then the magnitude of A plus B equals to 3. Okay, so in this case, they can be the same because they are in the same direction. The moment they are in different direction, which is, for example, in this case, I asked you to visualize it already, right? Vector A is actually 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7. This is our vector A. Then vector B is 4 to the left, 1, 2, 3, 4, and 3 up. This is my vector B. They are in opposite direction. Not opposite, they are in different direction. So I cannot simply add up the magnitudes to get the overall magnitude. Okay? Rather, what A plus B looks like is this. This is A, this is B. So the magnitude of A plus B will be the magnitude of this line. A plus B. And obviously, the magnitude of A plus B cannot be the individual sum of A and B. Okay? It has to be shorter, as clearly shown in this triangle. So A plus, when I want to find the magnitude of A plus B, what you need to do is to do the vector addition first. We do A plus B like this. Okay, just as what you have been doing in the previous example. Once you have the vector already, then you find the magnitude. Make sense? All okay? Okay, then we will try it. Try 12. I'm not interested in A and B lah, because you can do it yourself. What's the working? What's the working? Okay, so I show you the presentation. This is what you can do. Magnitude of A minus B, draw the vertical lines first, then just substitute in your A and B. So 2, -6, minus 3, -1. So continue with the magnitude. 2 minus 3 is -1, -6 plus 1 is -5. So I want the magnitude of this vector. And that will be given by square root of 1, okay, if you want to be complete, -1 square plus -5 square. And this is the positive square root because we are looking for magnitude, which is a positive number. So square root of 26. So you get the answer, round it off. Correct? Got that? And you see that, okay, and you see that it is actually not equal. So A minus B is not equal to, the magnitude is not equal to the magnitude of A minus magnitude B. Okay, so just write down, that is false. That's the answer. Can? Okay, next one. Let's try doing this together. It's a regular hexagon. What do you understand by regular hexagon? Okay, interior angles are all the same. What else? The sides are the same. They have the same length. Okay, that is important to us, right? For vectors. What can you tell me about this angle over here? Can you tell me the value? Divided by 6. So this is 60, right? Do you remember how to calculate the interior angle of a hexagon? What is it?
N minus
Okay, what is n? Value of n? 6 minus 2. Then what? Times 180 divided by 6. Okay, very good. This will give us 120. Okay, so if this is 120, can you tell me how much this is? 60 lah, yeah, 60 lah. Then this also 60, right? This also 60, right? So these are equilateral triangles, right? So since we said that this side is the same as this, same. Basically, all these lines, they have the same magnitude. Okay? They all have the same magnitude. All the angles that you see over here, all the acute angles are all 60 degrees. Okay, so that is our regular hexagon. Now, we let O be the center. Try and follow this example. Let O be the center. AB, where is AB? Okay, AB is over here. It is equal to vector P. Then CD is equal to vector Q. CD, okay, starting from C to D, that will be our vector Q, and EF is vector R. Identify the vectors which are equal to Q. Okay, come. What's the vector that is equal to Q? What? How can R be equal to Q? They're in different direction. AF. Okay. So we got AF is equal to Q. What else? Any more? No? Huh? No, I still at Q. There's some more. What else is the same as Q? EO. OE. Okay, very good. Any more? BO. BO. Any more? That's all? Yeah, that's all. Okay, what about R? Oh, again. Okay, what else? What else? DO and OA. So we see that they are all equivalent. Huh? Now I express the following as a single vector. P plus Q plus R. Do the brackets matter over here? No lah, because when I do 1 plus 2 plus 3, I can simply remove the vectors. So just adding them up. Okay, so now P plus Q plus R. I will start over here, right? So this is my start. So I trace it out. P, then plus what? Q. Where's Q? Oh, wait, that was P. Sorry. So this is the start. Okay, P, then plus Q, right? Where is Q? Then, but how do I go straight to this part? No, I can't. So I have an equivalent vector called, what is an equivalent vector of Q? BO. I want it to start from B, then to O, because this is also Q, right? They are the same. We identified that they are the same. Okay, so now my path is continuous. A to B, B to O, and I still need to plus R. So plus OA. So where, I ended here. So what is the answer? What is the answer? I start, I end at the same point. So what is this vector called? Okay, so the expressed as a single vector, right? So we can call it A, or we can call it the zero vector. In this case, it is not class. In this case, it is not useful to write 0, 0 like this. Class. It is not useful to write it like this because I don't have my x and y axis shown. Okay, so it is not useful. Now, next one, Q minus P. Okay, try it on your own textbook. Q minus P. Go and trace it out. What do we have? It's actually CE. We just follow this, the start. And we go Q minus P. This is negative P. So this is our N. So it is resultant CE. Okay? Do we have, just for the fun of it, do we have equivalent vectors to CE? What is it? BF, yeah. Can you see? The BF is actually the same as CE. If you draw a line, they are the same lah. Okay, so either answer will do also. Okay, next one. Q minus P minus R. Okay, try it. Do it. Q. This is my start. Q, then minus P. So I go this way. This is minus P. Then I need to minus R. But R goes this way, right? So I need to go this way. This is negative R. Then this is my N. But it doesn't have a letter over there. This is my start and this is my end. So I can actually translate everything down and to the left. So this is actually my answer from start to the end. The one in blue, it is the same as this, BE. Okay, so the answer is BE. Do you all have the arrows above the letters to indicate that they are vectors? You must have the arrows. If you don't have this arrow, right, then you'll be wrong. Because then you are not telling me about direction. Okay, so you see, this is the working that you can do. But if you know how to draw the arrows, you know how to flip them around, then it is not necessary to show them here. Just do it. Okay, let's try 13. Answer for A part 1. A vector that is equal to B. MD, yeah. Okay, so A part 1. Answer is MD. Do you put the arrow above? Okay, good. What about B part 1? A plus B plus V. Okay, that's AE, good. And the last one, part 2, A minus B. A minus B, AB. Okay, good. Now, I said that we cannot do part 2 over here to find equivalent for V because they didn't give information. But if I were to change the question to become D, E, C, B is a parallelogram. Now we can do it. Okay, so let's include this and attempt part 2. What is an equivalent vector for V? BC, right? Okay, so A part 2, our answer will be BC. Then for what about B part 3? A minus B minus B. A minus B, then minus Okay, so what's the answer for part 3? No. No. A minus B minus V. Okay, so what's the answer?
A minus B.
Okay, this is your homework.